catching up on some light reading, studying Saccharomyces cerevisiae. In any event, today we're going to be doing Lab 1 from the AP Biology Lab Manual, which I just carry with me. This lab focuses on diffusion and osmosis. In this lab, we will explore the relationship between solute concentration and the movement of water through selectively permeable membrane by osmosis. Diffusion is the spontaneous movement of a substance down its concentration gradient, from a region where it is more concentrated to a region where it is less concentrated. When a substance is highly concentrated on one side of the cell membrane, the substance will diffuse through the membrane of the cell until the substance reaches equilibrium, an even distribution of the substance on both sides of the membrane. Osmosis is the same process, only with water. Osmosis is the diffusion of water across a selectively permeable membrane. Water, like any other substance, wants to reach equilibrium. The water wants to diffuse to the higher concentration so that levels of the concentration will be balanced. As water starts to diffuse through the process of osmosis, the water begins to dilute the higher concentration of the sugar so that the concentration will be the same on both sides of the selectively permeable membrane. The purpose of this lab is to investigate how much water can diffuse into a cell based on how much sucrose concentration is inside of the cell membrane. In other words, the lab focuses on how the rate of osmosis changes as the solute concentration increases. Wait, what's that noise?
Move your hips, do your thing. Get off the wall, don't matter what they think. From your fingertips to your toes, you know you hot, so let everybody know. Gotta take it low to the floor. From the hills to the streets of the ghetto, hips don't lie. So move 'em up, we ain't gonna stop till we see everybody's bottoms up. Bottoms up, 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 y'all. Bottoms up, bottoms up, yeah. Miss Kiki P, looking extra glossy, got a dip your style, looking extra flossy. I'm bossy, but I keep it cute with my stunner shades on in the tree of my boots. Got the shots house swagger and I blocks it full. Yes, Mudville, baby, we don't take no bull. We keep it rocking.
Hello?
Sorry to bother you, but are you doing an AP Bio lab on diffusion and osmosis?
Yeah, I am. I'm doing Lab 1 right now. Who are you?
Well, my name's Carlos Jackson, and besides being known for my sickle cell anemia disorder, I'm actually pretty good with diffusion and osmosis.
Okay, you want to help?
Yeah, I'd love to help. Can we start right now?
Yeah, let's go. Come on.
Hypothesis. As the solute concentration goes up, the rate of osmosis must go up. The water wants to diffuse to the place with the highest concentration of a solute. So in the lab, the water must therefore diffuse the most to the greatest concentration of sucrose. The dialysis bag should fill up with water and get heavier as the solute concentration increases. We start by placing 6 separate 30cm strips of dialysis tubing in a bowl and soak them in distilled water until soft enough to work with. Once soft enough, we take a strip of dialysis tubing and tie a knot in one end, making sure it is tight enough so no liquid can escape that way. We do the same process in all 6 bags. Next, we take one piece of tubing and open the opposite end of it. While holding it open, we pour roughly 15 to 20 milliliters of 1 sucrose solution in it.
Watch your moving and elliptical What you say is way too complicated. For a minute thought I couldn't tell how to fall out.
Then, the top half is tied off tightly, but leaving a little room with no air bubbles in the bag for water to enter and expand. The same process is used for the remaining 5 solutions. Next, each dialysis bag is wiped to remove any external liquid, which would alter the initial weight of the bag and throw off the data. Then, each bag is weighed individually to record the initial mass. Each bag is then placed into separate containers filled with distilled water. Then we wait 30 minutes for osmosis to occur. After 30 minutes, each bag is removed from the water and placed on a towel. They are then wiped dry again to remove any external water. Finally, the mass of each bag is recorded once again. Thank you so much, Ryan, for letting me help out with this AP Bio Lab on diffusion and osmosis. I had so much fun.
No problem, Carlos. That was really fun. Now let's look at the results.
Sounds good to me. These are the results from the initial masses of the bags, the final masses, the mass differences, and the percent changes. Percent change was found by dividing mass difference by the initial mass and multiplying that by 100. Furthermore, as the sucrose concentration increased, there became a greater mass difference and percent change increased. The graph is almost in a straight line and resembles a constant rate of increase in osmosis. As the results showed, the increase in sucrose concentration made it so more water would have to enter the dialysis bag. The water wants to diffuse into the dialysis bag because the water must reach equilibrium both inside and outside of the bag. The one question that arose was why the 0.6 molar sucrose and the distilled water were out of line. The potential error is probably a result from air bubbles or the end of the tied dialysis bag leaking in some water or sucrose being let out. Also, not all of the water could have been wiped off the bags before they were weighed, thus changing the mass. Everything else seemed to work nicely. In any event, the concentration of a solute does in fact increase the rate of osmosis, which is clearly shown by the graph in the results. Also, the observations made from the mass changes and percent changes were correct because the increase in mass difference clearly showed that the more water was entering the simulated cell membrane corresponding with the concentration sucrose, which is evident in the results. Osmosis, the diffusion of water, is affected by the solute concentration because the water must diffuse with the solute in order to reach equilibrium in both the dialysis bag and the water on the outside. Another way of demonstrating diffusion could be spraying various concentrations of perfume into a room. The higher concentrations of perfume will obviously be more pungent in a wider radius, while the lower concentration will not be as strong. The difference in pungency is a direct result of the diffusion of the various concentrations. The higher the concentration, the higher the rate of diffusion. This experiment relates to one of the biggest concepts in biology, the activity of human cells. The rate of diffusion is affected by properties of the cell, the diffusing molecule, and the surrounding solution. Furthermore, many substances like water, ions, and molecules needed for cellular processes can enter and exit the cell by passive diffusion or by facilitated diffusion. If it weren't for diffusion, cells would not be able to survive.
Here's my key, philosophy. A freak like me just needs infinity.